Agrivoltaics are a combination between crop cultivation or livestock farming and the production of renewable electricity using photovoltaic panels. The idea behind it is to use land or a piece of land already used for the production of crops or farming in general, to also enable it to produce electricity for citizens, as well as obviously providing complementary income for the farmers. Using solar panels on top of crops or using also them for livestock farming, it comes with side benefits because you can use these solar panels to actually protect whatever is underneath against adverse effects of climate change or against, let's say, in general, any kind of extreme weather events. Let's go back to what the standard agrivoltaic panels are today. They consist of rows of solar cells, and in between two rows of solar cells, a gap that is left free so that the light can actually enter and hit the crops below. As the solar cells are actually absorbing the sunlight, they are actually made for that, this will result at the crop level into a chessboard-like pattern. So it means an alternance between full light and full shadow, full light and full shadow. And this comes with a big drawback of slowing down the growth of the plants and potentially also overheating the top of the canopy, the top of the plants. We're working at EURAC Research on a specific type of agri-PV panels. And what is special in our panels is that we try to overcome this issue, this chessboard-like pattern, by engineering the areas between the rows of solar cells in our panel, and more specifically by making them diffusive. And in doing so, thanks to the diffusivity characteristics that we bring to these areas, we provide three benefits. The first one is that you can smooth out during the day the variations of light, so you don't have this chessboard-like pattern that the plants don't like. The second one is that you can better distribute the light inside the greenhouse because it's going to be reflected everywhere, and ultimately reach also the leaves that are below, like the lowest leaves in the plant, thereby promoting homogeneous growth and optimal growth for the plants. And the last but not least advantage is the fact that you can lower by far the temperature at the top of the plants, preventing the plants from actually suffering from too much heat. So what is special about our panels at the end of the day is that they can provide diffusivity with the aforementioned benefits without sacrificing on the electrical production, which obviously is what we want to keep.
Through different 3D modeling softwares, we can actually simulate how light in these diffusive panels behaves. In these simulations, we're able to simulate different leaf shapes, and also we can understand better the shading of these leaves. We can size them to the specific plant dimensions, also the amount of branches that we have and the height, and then we can understand better the light that goes through the plant to the different layers of leaves. Module manufacturers, they can understand better, okay, what is the best cell positioning for their modules, what is the best encapsulation materials to enhance their diffusive properties. So we can take those measurements from our labs and actually put them into the simulations, and we can give recommendations how to optimize their PV modules, and also for crop producers, how they can optimize their PV system.
So we did the screening, we defined the good combinations of materials, And then thanks to the prototyping lab that we have in our facilities at Durac Research, we were able to actually design and produce exactly the modules that we wanted. So then we produced the modules with all the components like the good recipe that we identified. And now we installed them already a couple of months ago outdoors in a dedicated agri-PV bench, where we are now investigating the effect of having these solar panels as covers on the growth and on the health of salad, typically, salad crops. So yeah, basically at the end of the day, I think we try at Durac Research in this project to bring our contribution through upgraded agrivoltaic solar panels that ultimately may allow to have better social conditions for farmers, that can ensure food security and sustainable production on the long term, as well as providing a shield against adverse effects of the long-lasting climate change that we have ahead of us.